So we're going to work on graphing linear inequalities today, just linear equalities, not even systems yet. So we're going to practice this for a couple of days, and then we'll start working on systems of linear inequalities. So you should have this paper and be on this side, the one that says staple into your notebook, February 7th. Obviously, it's not February 7th, it's February 12th. So an inequality means not equal, just like we talked about yesterday, less than, greater than, less than or equal to, or greater than or equal to. So we're going to do two examples, and then I'm going to have you finish this independently. This is going to go into your notebook. So on the first one, we have y is greater than or equal to 9/4 x minus 5. So we're going to rewrite our inequality as just an equation. So y equals 9/4 x minus 5, and you should be writing just like I am. So we're writing it in slope-intercept form, which is right up here. Remember that b is your y-intercept, and m is your slope. And when we are graphing, we do b first, and then we do slope. So we're going to graph this one b. On this is -5. And the slope is 9/4. So first I'm going to go down to -5 on the y. 1, 2, 3, 4, 5. And then my slope is 9/4. So that is written as 9/4 or -9/-4. Remember, you can change the sign, but you have to change the top and the bottom. So I'm going to use the positive version because I can't really go down. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and then right 4 because it's a positive 4. 1, 2, 3, 4. So far everything has been the same as when we're graphing an equation, and here's where it gets a little different. You're going to look at your inequality sign. This one is greater than or equal to. If it is greater than or equal to or less than or equal to, our line is going to be solid. If it is just less than or just greater than, then we're going to use a dashed line. This time it's greater than or equal to. So with your ruler or a straight edge, you're going to draw a line, and it's going to be a solid line for this one. A line always has two arrows, one at each end. Okay, so far, same. The next thing that we're going to do, this is where it gets a little different, is we're going to test a point. You're going to choose a point on either side of your line. So it could be on this side of your line or this side of your line, as long as it's not on the line. And it really doesn't matter which point you choose. I always, if I can, choose 0, 0. And I'm just going to mark it just so I can remember that I chose 0, 0. So I'm going to test 0, 0. That's to see if 0, 0 is a true statement when I plug it into this inequality or a false statement. So I'm going to plug the point 0, 0 in for y is greater than or equal to 9/4 x minus 5. So remember that our ordered pairs are x, y. So I'm going to plug a 0 in for x and a 0 in for y. And there's a little bit of space for you to do that, but if you need to do it on a separate sheet of paper, feel free. So this is going to be where I'm going to put my ending solution. So 0 is greater than or equal to 9/4 times 0 minus 5. I know that 9/4 times 0 is 0. Anything times 0 is 0, and 0 minus 5 is -5. So 0. So still have 0 on that left, and 0 minus 5 is -5. So now I look at this statement. Is 0 greater than or equal to -5? And I need to decide, is that true or is that false? And it is true. So that means that anything on this side of the line is going to be a true statement when I plug it into this inequality, and anything on this side of the line is not going to be a true statement. So my next step is to shade the side that has a true statement. So shading just like that. So that means all of this stuff and on up in that direction is true. So this is my solution. And it includes the line because it's a solid line. If you had gotten a false statement, so you don't need to write this, but if you had gotten -5 is greater than or equal to 0, that's a false statement. So that means you wouldn't shade here, you would shade down here. Okay, so if it's false, you shade the opposite side. If it's true, you shade the side that you were testing. All right, let's do number 2. we have y is less than negative 7/3 x plus 3. We're going to rewrite it as an equation. So I just changed that to equals. B, or your y-intercept, is 3. M, or your slope, is negative 7/3. So I could write that as negative 7/3 or positive 7 over negative 3. And I'm going to graph that. So I start at positive 3 on the y. And I can either go down 7 and over 3 or up 7 and left 3. I don't have space to go up 7, so I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7, and right 1, 2, 3. Okay, so now is where it's a little different. We're going to decide, is it going to be dotted or solid? And I see that it is less than, and I look over here, anything that doesn't have or equal to is dotted or dashed. So I still am going to use a straight edge. Remember, I have tons of rulers if you need a straight edge. And I am just going to dash it and still put your arrows because it's still going on forever. It's just not including it. So what that means is whatever side I end up shading, it doesn't include this line. So it's up until that line, it just is not on the line. So I'm going to test a point. I'm still going to test 0, 0 because 0, 0 is not on my line. So I'm going to test the origin. I do that because 0 is so easy to plug in, and it's easy to multiply, it's easy to subtract from, it's easy to add from. So I have y is less than, I should have plugged a 0 in because I'm plugging 0 in for y. 0 is less than negative 7/3 times 0 because there's an x there, plus 3. 0 is less than 0 plus 3, and I know that 0 plus 3 is 3. 0 is less than 3. That's a true statement. And so I'm going to shade toward my true statement, okay? So I'm going to shade this way. Okay, so that means that all of this is true, okay? So all of this is true. Everything up to that line, but not including that line. I want to give you an example real quick of one where it's not going to be true, just because so far all of ours have been true. So let's see why. Okay, let's see. Trying to find one. Okay, let's look at number 8 on the back. Okay, so our equation, if we rewrite, so make sure you're on number 8 on the back, we're going to rewrite our inequality as an equation, 5/3 x minus 5. My y-intercept is negative 5 because we take that whole thing, and my slope is positive 5/3. If I needed to, it could also be negative 5 over negative 3. Okay, so I'm going to graph it. Come down to 1, 2, 3, 4, 5, and then my slope is 5/3 or negative 5. I'm not going to go down, I'm going to go up. 1, 2, 3, 4, 5, positive 1, 2, 3. I look at my inequality sign and it's less than. So dashed line or dotted line or not a solid line. Line means it goes on forever, so don't forget those arrows. I'm still going to test with 0, 0 because it's not on my line. So 0 is less than 5/3 times 0 minus 5. So 0 is less than 0 minus 5. 0 is less than negative 5. Okay, so I know that 0 is not less than negative 5 because negative numbers are below 0, so that's a false statement. So that means this 0, 0 is not true. So I need to shade the other side because this stuff is not true because this is the side I tested. So if this is false, then the opposite side is true. And you could test that. You could choose another point. You could choose, this is, I don't know, let's see, 1, 2, 3, 4, 4, -1. So -1, oops, 5/3 times 4 minus 5, so that'd be -1, 20 over 3 minus 5, so that's like 6, 7-ish. -1 is less than 7 minus 2, which is 5, or 5, which is 2, so -1 is less than 2. So I'm just showing you that it is true, the opposite side, but you only have to test 1 point. So I would always test 0, 0, because look at all that math I had to do. This one I can literally do in my head. Okay, so your job today is to finish. You have 3, 4, 5, 6. You have 7, 9, 10, 11, 12, and use the steps that I said in my video and the steps that are given to you in each box to help answer these questions. Okay, and just use what I've explained to you. This needs to be stapled into your notebook. If you don't finish it in class, it is homework. We're gonna continue graphing one more day, and then we'll start systems on Thursday.